example, what we can do here is I will use earn. I have to use the data. It's a JTrain 98. Yeah, now we got a JTrain, and then we will do the regression. First regression is a simple just regression. So I will do the regression on 98 with the train on 96. So this is like a 90 earning in 1998. It's depend. Yeah, we may affected by the 96 earning plus education plus age plus married. Okay. Oh, yeah, we have to specify this data equals JTrain 98. Yeah, we did it, and then summary of the linear regression, and you can see what is the effect of the train. Train effect is the 2.4. We don't do regression adjustment, right? So this one is a 2.41, could be true effect of the train if this train is the randomly assigned through our whole data. But probably this train is not randomly assigned to our data. So can we do the regression adjustment? So yes, we can do the regression adjustment. So now we will do the regression adjustment. So we will do the regression using this one, right? This one, this model, W times something minus average and so on. So we will do on 98. Still, I will estimate on 98, and then train plus we will include everything on 96 plus education plus age plus married plus. Now I want to have a train times, because train is W here. Train is the treatment we want to find out of its effect, and then on, because train next one is earn 96 minus mean of earn 96, right? So again, if we using this one, the computer are trying to handle this mean earn 96 as a vector. So you will see the error if you learn this one. Okay, so if you learn this one, data equals JTrain. Okay. So you will see the error here. The variable lengths differ because this one is only one number, but it's trying to treat it as a vector and vector. So that's why you have to use here. Why? What you have to do is you have to use the I function here. So you calculate it first, and then take it as it is. Plus I, and then what would be the next one? This is education. train times education minus mean of education, right, plus I train times what is next? It's age minus mean of age plus I what else? Age and then married, right? So train times married minus mean of married Yeah, this is what I did. This is the train, earn 96, education, age, married, and also train times earn 96 minus mean. That's what I'm doing here. This is the right. So I calculated this is a train, and then all other single factor, and then train times on 96 minus average of on 96 and so on, right? So I'm doing that, and then if you do the summary of regression adjustment, oh yeah, I have a lot of typo here. Okay, so let's see, we can have a bigger screen. This is something wrong. Okay, here I think this is a parenthesis problem. This one, yeah, this one is including everywhere. I have to cut off out here. Okay, this is fine, and then this is fine, then this is okay. Sorry about that. I missed one parenthesis. Where is the comma here? Oh yeah, again the parenthesis problem. Now I can do the summary. Yeah, now I can see the regression result. The train, now the coefficient of the train, this is at 3.1062, is the regression adjusted estimation of the effect, average treatment effect of the train. So now you can see this is a lot different from the what we get. So the simple regression is 2.4. This 2.4 can be true if the train is randomly distributed, right, assigned. However, this is not true. So if we, again, this method is also not perfect, but we can consider this is a better estimation because we considered all this effect and then taking out that effect and then trying to capture what is the real, the pure effect of the train. Again, this is again is not perfect, but this would be better. So you can see the effect of train is greater than the simple regression cases. This is what we call the regression adjustment. How to find it of the estimation effect of the treatment. This is another way. Another way is actually the idea is very simple. We can have a separate regression, so you can divide the data set in two separate out, trained data and untrained data. So everybody who has a train and everybody who didn't have a train, and separate out, and you run the regression, two different regression. Once you have a two different regression, right? And then you will, which means you will get all these numbers, right? So you have a complete model, and then you predict everybody again using this given x value, right? And then calculate the difference. So you predict what would be, actually here you taking out, we are not using the w here, without w. Because this everybody w is a 0 here, everybody w is 1 here, so I don't use a w in independent variable here. And then you predict using this formula, so you will have each individual's data. First person has a x1 is like a 3 or something like that. Second person, third person, but first person also has a w is a 0 or not, right? Second person is a 1 or 0, but using the first person's information without using the w, only using the other value, you can predict what would be the y0 for this person. And then you can predict also y1 of this person. Now this person actually has a w0 or w1, only one of them. But since you have a two different model, regression model, you can predict y0 and y1 from the one person. And then you calculate the subtraction. So each person will have a y1 minus y0. Observation. Okay, and then you calculated the average, which means a summation and divide by n. If you calculate the average of the prediction, actually this is estimation, and you can calculate the predict value of the ATE. This is another way to calculate it. So this way you will get a same average treatment effect you got from the regression using the interaction term, but you cannot have the standard error and so on. So it may not be easy to run the test, but the idea is pretty simple. How can you calculate the expected average treatment effect? You using the two separate regression model, you just predict the y0 and y1 from the one observation, each observation, and then you calculate the difference between these two estimation, and then calculate the average. That will be the average treatment effect. That's an easier way. However, it's not going to be easy to find out, statistically significant or not. You cannot tell. Okay, that's the end of this chapter.